The Automated Podcast.
Welcome back to another episode of Automated. My name is Mark Verbenkov, and this, of course, is the podcast exploring the impact of technology on jobs. So today we're looking at autonomous vehicles, and this is actually a technology that I've been quite interested in for the past several years, especially as they are one, if not the most visible automation technology to most people today. And they really seem to be close or very near ready for mainstream use in many parts of the world. So 2 weeks ago, I even went to a workshop in Brussels where there was a project that was presenting the results of a 3-year study showing the impact of autonomous vehicles on jobs over the next 10, 20, and 30 years. So though it specifically focused on the impact within Europe, most of the points that were mentioned were actually relevant for other parts of the world, but I'll be talking about this a little bit later on in the episode. But why don't we start off by looking at what autonomous vehicles actually are. So though I'm sure many of us think of cars when we talk about autonomous vehicles, as this is really the most publicized application, it's actually a bit more broad than this and includes other technologies like trucks, planes, boats, as well as trains. So artificial intelligence is really the key technology in the development of autonomous or self-driving vehicles, and it enables them to make their own decisions without any human intervention through the continuous collection and analysis of data. So as mentioned in the previous podcast episode on artificial intelligence, really the massive amount of data that we collect nowadays is absolutely key to enabling artificial intelligence as well as self-driving vehicles. And the most important data for autonomous driving systems is real-time object detection. So to enable this, a ton of different types of sensors are used. The main ones are typically cameras, radar, and LiDAR. And this is a laser-based radar, which is safe for everybody's eyes, that creates a 3D image of the nearby surroundings. There are also many other types of sensors that are used. I can rattle off a few of them here. There's inertial measuring units, GPS, vehicle to everything or V2X communication, as well as high definition maps. But all of the data that are taken up by these sensors are united together and they generate an understanding of the environment. That's their main function. And then through a certain AI-based system, decisions to react accordingly to the environment are made, and actions like steering or applying the gas or thrust are taken on by the system. So needless to say, this is absolutely most challenging for a normal road vehicle that has to interact with dozens of other vehicles, pedestrians, signs, different speed limits, as well as the random accidents that come up. So this is why higher levels of autonomy already exist in other transport modes. So in case you didn't know, commercial passenger planes are already roughly 90% automated, and both fully automated boats and trains are already in use in different parts of the world. So I actually lived in Toulouse, France a few years ago, and on the first day that I moved, I had to go and use the metro to get to a different part of the town, and when I got down in there was absolutely nobody at the controls. It was completely automated, and it was really interesting to see. Though this is perhaps one of the easiest transport modes to automate, as it is a completely or near completely controlled environment with predefined stops as well as times. So I just want to touch on one small thing before diving a little bit further into the episode, and this is on the levels of autonomy. So there are 5 levels of autonomous vehicles, and it's classified from 0, which has absolutely no autonomy, to level 5, which is complete autonomy. You don't even need a steering wheel. The car will completely drive itself, while level 4 is able to do most actions autonomously, but a driver still needs to be around and paying attention to the road, most probably with their hands still on the steering wheels. So I'll have a link to a description of the different categories in the show notes, but just keep in mind for the episode that level 5 is full automation. So moving on, we can look at a brief history of the autonomous vehicle, and it was actually in 1939 that General Motors held an exhibit with the very first self-driving car. So although this car was electric, it was guided by magnetized metal spikes that were embedded in the roadway. But it wasn't until 1958 that this actually became a reality. So the car's front end had a bunch of embedded sensors into it that could actually pick up the current flowing through a wire that was embedded in the road. And this current could actually manipulate or tell the vehicle to move either left or right. So though I think it's actually pretty impressive that something like this existed back in 1958, it's still more like an automated highway system than an actual vehicle. And I think that the costs to implement such a thing would be extremely high, especially if this was to go into most highways across the world. So many attempts since then have occurred across the world in order to create other types of autonomous vehicles, but it really wasn't until the early 21st century that autonomous vehicles gained mainstream attention through the DARPA Grand Challenge. So this was a challenge that had a $1 million prize and would be awarded to the team that would be able to complete a 200 kilometer plus driving course through the Mojave Desert in the United States. So DARPA is actually a research department of the US military and was really hoping to use the challenge to drive autonomous vehicles for the US military. A year later, in 2005, a second challenge was held, and 5 of the 21 teams actually completed the course. And since then, improvements in the technology have led to millions of kilometers driven by self-driving cars. Google's self-driving car, now developed by Waymo, is actually leading the charge with several million kilometers having been driven by their vehicles that they're testing. And along with cars, planes also have a high level of autonomy. So as mentioned before, most commercial flights have used autopilot systems for at least a decade now, and this has reduced pilots' actual control of the airplane to around 10% of the entire flight time, and this is usually just relegated to landing and takeoff. So essentially, we have had level 4 autonomous planes for years now. And with Boeing's new autonomous fighter jet set to hit the skies in 2020, as well as a German research institute recently building a control system for small aircraft, it's really not hard to see that the age of flesh and bone pilots is coming to an absolute end. And this same trend is really continuing for both boats and trains. In May of 2019, an autonomous boat that was a 12-meter long uncrewed vessel called the Sea-Kit Maxlimer, if I'm pronouncing that correctly, already made a commercial run from the UK to Belgium carrying boxes of oysters. It safely navigated what is considered one of the busiest shipping lanes in the world. And then in Western Australia of June of this year, the Rio Tinto completed the transition to a fully automatic, driverless operation of its entire heavy haul rail system, making it the world's very first fully automated mainline rail network. So with just these few examples, you can really start to see that transportation in general is starting to make its move towards being fully automated. Though we are probably roughly connected to the scope of both the car as well as plane usage, I'll take a quick second to sketch the size of rail and maritime usage. So though it's still a huge and highly profitable business, railroads actually move less freight than they did 10 years ago. And their biggest customer, the oil industry, is really in long-term decline with the advancement of alternative energies. So worldwide, almost 70 billion in cargo moved by train back in 2017. But to put this into perspective, trucks carried over 12 trillion. But this is still nothing compared to maritime transport, as over 90% of the world's trade is still carried out by sea, and it is actually by far the most cost-effective way to move goods, as well as raw materials around the world. So let's turn our attention now to the impact of jobs. So the main concern with all forms of self-driving vehicles is really the number of people that directly depend on driving vehicles for subsistence. So worldwide, there's some estimated 6 million truck drivers, 18 million taxi drivers, while there is under 1 million pilots, train and rail conductors, as well as boat captains. So this number is actually doubled when we start talking about those that are indirectly employed. So examples of this would be repair, as well as maintenance, or food and service to those that are actually driving the vehicles themselves. So though the jobs have, of course, changed over time, they have really existed for hundreds of years with not very dramatic changes. So I think a good example of this is the taxi driver, who doesn't really need a very different set of skills compared to the horse and buggy driver of the past, as essentially steering, object recognition, as well as geographical awareness haven't really changed substantially. And this has really enabled low-skilled individuals an opportunity to make a living with minimal training requirements. So if these primary jobs, right, considering the drivers, are eliminated, which really seems to be the trend that we are moving towards, then it seems that a really profound change is going to happen in job availability as well as skill requirements, which will really hit the low-skilled individuals much more substantially. So I won't be professing any kind of solution to this, but in the workshop that I attended in Brussels, they did identify that this was a main cause for concern. So the workshop also identified the overall trend that low-skilled jobs and specific tasks within those, an example of this would be like attaching a boat to a dock, will be replaced by automation solutions. So jobs that do remain will move much more towards monitoring and supervision, like remote operating a boat or a truck. And a good example of this is that the first autonomous truck actually hit the Nevada highways all the way back in 2015, but they still had a backup driver in the truck monitoring that there were no accidents or nothing that went wrong with the truck. What is interesting to note, though, is that just like remote drone operators, it will be possible to have remote truck drivers, and these will be operating perhaps as many as a dozen trucks at a time, but only taking control of the wheel in case of an emergency or in case of something going wrong. And I think this idea really feeds nicely into the next point, where new jobs will, of course, constantly be emerging. Some of them that were identified in the workshop were automation and robotics experts, data scientists, as well as legal and privacy experts. However, I think a really central and still very unclear point to all of this is whether the new and emerging jobs will be able to make up for the quantity of jobs that will be eliminated. And I think that this is a very central issue through all of the technologies that will be talked about in this podcast. So one other question that I personally have is connected to the difference in the education or training time required. So driving a taxi requires far less training time than a data scientist does. So as these higher skilled jobs become more common and the less skilled jobs become less common, questions of educational support might have to be brought up, as there might be far less jobs available for when you need to take a 4 or 7 year educational program. So if I can bring in a personal anecdote here, I was actually a film projectionist for a movie theater during my university days, and I had to memorize the very intricate loops that the film needed to take through the projector. But this was all learned over the course of a week or so. And if you messed up, the entire movie could be stuck on a single frame until you took it out and re-looped the film. So a few years later, when I eventually went back to the theater to talk to a couple of my friends that were still working there, I found out that the projectionist position no longer existed, as the system was now entirely digital and all somebody had to do was press the start button. So I still know that there are movie theaters out there that still have the projectionist positions, but I think that as automation creeps more and more into these typical student jobs, it's going to be harder and harder for students of all ages to support themselves through their educational process. So another aspect of all this is the speed of the transition. So we can go back for a second to episode 2, where I discussed the transition from the horse and buggy to cars and how it took nearly 30 years for this transition to happen. And this slower transition allowed people to shift from one career to another. So many horse carriage manufacturers were actually able to become car or car part manufacturers and had their employees learn new skills in order to do so. So the shift from metal parts wasn't really that big of a shift for them, and many of the old skills were still very relevant to the new form of work. However, it can be argued that this might not be the case today, as autonomous vehicles require no driver, but do require data scientists or AI engineers or risk analysis consultants, as well as lawyers to deal with the new laws, which are really radically different forms of work. And we also have an advanced distribution and logistics industry compared to 100 years ago. So I'm really a bit skeptical as to whether this transition will take 30 years once the technology starts really being implemented. But then again, just because the technology exists doesn't mean that it will be deterministically implemented. So here in Barcelona, we have had numerous taxi strikes over the last year or two that have successfully shut out Uber from the city. However, I'm not so sure if there has ever been a successful long-term strike against a technology that provides better service, is more reliable, and is ultimately safer. But if you know of one, please let me know. So to finish this episode off, I did come across a couple interesting points that didn't necessarily fit into the things mentioned above. So the first one is kind of the social issues surrounding automation. So cargo boats and planes are probably going to be the first ones automated, as there are no human passengers in this transport mode. Cargo just makes it easier to accept. Even though there used to be 3 pilots in every single cockpit for the commercial airplanes, the move from 3 down to 2 was acceptable as the autopilot systems were engaged in most airplanes. But I think that the move from 2 to 1, or ultimately to 0, will be an order of magnitude more challenging for the public to swallow. So the other point was actually mentioned in the last episode, and this has to do with passenger drones that were actually first unveiled in 2016 at the Consumer Electronics Show. No commercial ones are out there yet, as this is still a prototype and it's really bogged down with legal and safety testing. But nevertheless, this does mean that there is a technology out there that will hopefully in the future enable personalized, automated transportation through the use of what they're calling your own personalized air taxi, which really just looks like a large drone with a central pod in it where you're able to sit and then be whisked away to wherever you need to be going. And then for the final point, there are the legal issues. That is a really big discussion point when talking about autonomous vehicles. So this really comes down to who is at fault in an accident with a self-driving car. Is it the driver? Is it the car manufacturer? Or is it even the software programmer? So this is way out of scope for this episode, but for a more in-depth look, I have a link to a paper in the show notes. So that's it for this episode. For next week, I'm actually still undecided on whether I want to look at the Internet of Things or blockchain first. So if you have a preference, you can let me know over Twitter and LinkedIn. And as always, please go to iTunes or wherever you listen to your podcast to leave a rating or a review, as it really helps out the podcast. Thanks for listening.
The Automated Podcast.